Let's look at a speed of light example. We know that wavelength is the length of one wave. The symbol for wavelength is lambda right there. Frequency is how often something happens. The symbol for frequency is nu right there. And speed is how far something travels per second. If we're dealing with electromagnetic waves, that speed is a constant. All electromagnetic waves, everything in the electromagnetic spectrum will travel at 3 times 10 to the 8th meters per second. So anything, radio waves, microwaves, infrared, visible, UV, X-rays, gamma, they all travel the same speed. Now they have different wavelengths, and the speed is related to the wavelength and the frequency. Here's my equation. C stands for the speed. That's equal to wavelength times the frequency. Wavelength is measured in meters. Frequency is hertz, which is 1 over seconds. Well, if you multiply a meter times 1 over seconds, you get a meter per second. So as an example, let's assume we're dealing with ultraviolet light. Right down here, something on the order of 10 to the negative 9th meters. So let's say I have light that is 4.2 times 10 to the negative 9th meters. And I want to figure out what is its frequency. Well, we can use the speed of light equation. Speed of light is wavelength times frequency, because all of the electromagnetic spectrum travels the same speed. So I know the speed is 3 times 10 to the 8th meters per second. That equals the wavelength, 4.2 times 10 to the negative 9th meters, times frequency. If you divide both sides by 4.2 times 10 to the negative 9th meters, we're left with frequency on the one side. Meters cancel out, and you're left with 1 over seconds. And when you do this division, 3 times 10 to the 8th divided by 4.2 times 10 to the negative 9, you end up with 7.1 times 10 to the 16th hertz. A hertz is the same thing as 1 over seconds.